Okay, so last class we have discussed till modified version of Ampere Circuital Law, right? Maxwell has modified Ampere Circuital Law because it was not applicable for certain regions where there is no wire carrying current, but there is some changing electric field or changing electric flux, and in that region we don't have any current, but still there is magnetic field in that region because there is a change of electric flux. That change of electric flux gives rise to magnetic field. So that is how Maxwell modified that equation. So let us write that modified version of that Maxwell Ampere law. Maxwell Maxwell Ampere Circuital Law. Maxwell Ampere Circuital Law. So what he modified is integral of d dot dl, line integral of magnetic field along a closed path, is equal to mu naught into current within that loop, but that current includes conduction current plus displacement current. And you can substitute displacement current also here. That becomes epsilon naught d phi e by dt. So that's the total law, modified version, Ampere Circuital Law, Maxwell Ampere Circuital Law. Okay, so this is the equation where we are going to use it. Now, already I discussed that if the region is outside the capacitor or they have not mentioned in the question, then you must consider area of loop as same as area of capacitor. But in case where they have mentioned that the distance is somewhere away, right, like that, if they mention, then you need to consider that area of the loop. Okay, so the idea is that if nothing is mentioned, we can take entire area of the loop as area of the capacitor, but if they mention, then we have to specially take care of that, and we have derived the formula also, right? Okay, so today we will take some questions in NCERT. There is a solved example, but not now. The previously old NCERT they had this question. So that question we will take and directly will try to apply the formula that we have discussed, and we will try to get the answer, right? And then we will see another question which involves a major application of this, whether it is NEET or NCERT or any other type of book you take. That model is a very good example. Okay, so let us take that first NCERT. Old NCERT, those who do not have, you can please download. Already I have mentioned in our app. Free materials I have already uploaded, and this old NCERT may not be available in internet also. Don't know whether it is there or not, but you check in our free material. Exemplar also I have uploaded NCERT physics books. Grade 12 folder you go, and this is chapter number 8. Chapter number 8 you open, you will find this. Okay. Now I will discuss that question. What is that question? Let us take that question first. NCERT. NCERT. This is example 8.1. They are saying that there is a capacitor, and this capacitor is connected with a switch, and it is connected with a battery of 2 volt, and there is a resistance here 1 million ohm or 1 mega ohm. This is the resistance, and this is the capacitor. This value of capacitor is 1 nanofarad. Capacitance value is given, and this is connected right? And the question is that switch is opened right now. Switch is open, but you close the switch or switch on at time 0. Time 0, this is switched on, and they are saying that this is the axis of the capacitor, and we need to find magnetic field at a point P, which is at a distance of some distance they have given, let us say small r, and total radius, which you can say as r naught, right? This total radius of this capacitor plate, circular cross section, that radius they have given as, total radius they have given as 1 meter, and this radius small r is 0.5 meter. Okay, now they are saying that find magnetic field. Question is find magnetic field at P when time is equal to 10 to the power minus 3 seconds. Okay, this is what question says. That's all. This is the question. So first let us solve this question with the formula that we have discussed. Using that formula immediately we'll solve it. Okay. This is the point where we want to calculate magnetic field. So note that inside there is no wire, so only current is displacement current, and that displacement current first we need to calculate. Displacement current we need to calculate, right? Because in the Ampere Circuital Law, which is modified by Maxwell, we need to know what is the displacement current. Now we don't have to write the entire formula and waste our time, right? You have to be smart because we have done that already. So once you have done that, you will use that, right? That's what is smartness. Why I will waste again my time? That's how you should study. Once you have studied, once you have derived a result, then you need to just mug up that result because you have derived it. And suppose if you forget, again you have to derive it. It is not very good to do that. Okay, it will not be considered as efficient as far as competitive exams are considered. Once you derive it, and if you forget it, you have to again derive it. It will be a waste of time. So better remember it, mug up the important results for competitive exams. Okay, that means you have to balance everything. You should know derivation, you have the knowledge, at the same time you have to mug up the important formulas. It's not that you are simply mugging up, right? You have to mug up, at the same time you know the background of that, right? Both the things should be there. Okay, so now we know the, first of all let us calculate the displacement current. Displacement current formula we already know, V by R e power minus T by RC. Here in this case, displacement current formula directly we will calculate that. What time they are asking, we can directly substitute that. Definitely we'll substitute that. Time we have to substitute. V they have given voltage, V is 2 volt, we'll substitute that. Resistance also they have given, resistance is mega means 10 to the power 6 ohm, substitute that. E power minus time by RC. What is time? What time they are asking? 10 to the power minus 3. 10 to the power minus 3. What is the product of R and C? Product of R and C first you calculate. R is 10 to the power 6. C is 10 to the power nano. Nano means 10 to the power minus 9. All of you should know. So 10 to the power minus 9. That means it is 10 to the power minus 3. So RC is also coming 10 to the power minus 3. So that means this is 2 into 10 to the power minus 6. E power minus 1 it is. E power minus 1. Right. So I can write this as 2 by E into 10 to the power minus 6. This I will write 2 by. Anyway, E I know E is nearly 2.718, something like that. So I'll just keep it as it is. And this is the current. So this is ampere. So we got the current, displacement current. Now we will use that formula. What is that formula? You remember, The direct formula we will use. If you want in board exam, if they give this question for 4 marks or 3 marks, you have to write all steps. If you want, you write it, right? If you want, you write it. Integral of B dot dl vector is equal to mu naught into current inside, which is conduction plus displacement. But conduction current is not there, so this is 0 and this is displacement current, which we already calculated. So now we will use this formula. So integral V dot dl means V into 2 pi r, 2 pi r, mu naught. Mu naught we have to calculate, right? And then displacement current. Displacement current we have got 2 by E 10 to the power minus 6. What do you remember? There was some factor of area ratios. Somewhere it was. Do you remember? Area of capacitance. Was it here? Displacement current? I think it was here, right? Because we are calculating the flux, so there was a factor of area of the loop by area of capacitor. Do you remember this? Yes, there was a factor area of loop by area of capacitor. Area of loop by area of capacitor. Yes. So here we have to take that area of loop by area of capacitor. Now tell me what was the area of the loop? Here loop is what? Where is the loop which you are going to make? This was the loop. So area of the loop is how much? We know area of loop is how much? Area of loop is pi small r square. Area of capacitor is what? Pi into r naught whole square. So what is this ratio gives? What does this ratio gives? Area of loop by area of capacitor. Pi will get cancelled. R square by r naught square. That means r by r naught whole square. R is half of r naught, so 1 by 2 it is going to happen. So this factor will come 1 by 4. 1 by 4 extra factor is also coming here. Note this. So 2 by e 10 to the power minus 6, 1 by 4 it is also there. So 1 by 2 e into 10 to the power minus 6. This is ampere. This is displacement current. We will now substitute that. So let us substitute this displacement current. That's why it is very important to remember formula completely. So B into 2 pi r is equal to mu naught. This I have written, right? So 1 by 2 E I have to edit this displacement current. I got it. 1 by 2 E. Then I will calculate B. B we want to calculate B. So B is equal to mu naught by 2 pi into 2. 4 pi. Right? 4 pi R into E. R E into 10 to the power minus 6. Mu naught by 4 pi I will write as 10 to the power minus 7. R, that R is 0.5. E is there, right? Into 10 to the power minus 6. Now calculate answer. Calculate the answer. So this will go 2 by E only, it is going to come 10 to the power minus 30. So check out the answer, it will come 0 point something. I think that you have to calculate because the value of E is nearly 2.718 into 10 to the power minus 30. Check out this, how much it will come. Tesla, unit will be Tesla. How much? Suppose I multiplied extra factor 10, so this become 20 divided by 2.7 approximately into 10 to the power minus 14. I will take. Now calculate what is 20 by 2.7 or what is 200 by 27. Calculate this. This all of you can calculate. 27, 9 I cannot take. 9 will go. Suppose if I take 8. 8 into 7 56, 8 into 2 16. Nearly I think it will come 8, right? Suppose if I take 8, then 8 into 7 56, 5, 8 into 2 10, 10 plus 15, correct? 9 times can it take? 9, 9 7 63, 6, 9 to 18 plus, no, it will become large. I think nearly point, this factor may come as 8. So nearly or approximately 8 into 10 to the power minus 14 Tesla. Approximately. Check out this. Yes? Clear? Are you getting this? Calculation you can take care. If one digit after decimal, I can do that. It may come 7.9 or something, but I have just taken up to one digit. 8 into 10 power minus 4. Clear? Anyone any doubt in this? Tell me. Anyone any issue in this problem? Let me give you the exact answer. The exact answer is nearly 0.74. I think we need to take up to two digits. That will be better because this approximation I have done. Okay. So 20 by 200 by 27, how much exactly it will come? 8 will go more than that. Take 7. 14. 7 into 2, 14. 18. Correct? Check out this. 6. Take that. Then how many times? 4 times it will come. 7 into 4 into 2. 4 times is correct or 5 times should I take? 189 I think it was. Right. Okay. So this is 1. This is 11. Okay. An extra factor 10 will come. Right. So then 4 times will take. Yeah, it will come nearly 7.4. 7.4 into 10 to the power minus 14. Tesla, the unit will be Tesla. Clear? This calculation you can check. I think this is not very big calculation. Clear? This is the correct answer. All of you have got this. All of you have understood this. So if this type of question comes in your board exam or it comes in your NEET or in JEE main, you can solve this type of problem, right? Why are we taking that area factor? That is also important. The area factor is coming because this radius is smaller than that. If this radius was equal to this R naught or if this radius was greater than R naught, then area factor is going to be 1. This factor area of loop by area of that is going to be 1 because we discussed last time if the point is away, radially away from that capacitor, then we will take this as 1. Clear? Yes? So I hope all of you got this. Now let us go to the another question. Next question. In NCERT, is there any other question on this? Check exercise, old book exercise. I think this was one of the questions was given. NCERT exercise. Any questions are there? Okay, let us try a few questions on NCERT. Question number 1, 8.1 exercise question you take. Exercise question 8.1. Figure 8.6 shows a capacitor made of two circular plates. So there are two circular plate capacitors shown here like this. Okay. And they are saying that circular plate, the radius is given for this. This radius, let us say R naught. This R naught value they have given as 12 centimeter. Separation is also given. Let us say separation is D. This D is given as 5 centimeter. So capacitor is being charged by external source, not shown in. So it is being charged, so current is increasing. I equal to dq by dt. The charge will be developing, some charge plus q, some charge minus q. Capacitor is in charge. This charging current is constant. Okay, this charging current, this I they have given here. They have said that this current is constant. dq by dt is given here as 0.15 ampere. Charging. Calculate the capacitance rate of change of potential difference between. We need to calculate the capacitance. That's the first part of the question. Let us solve that. So first part they are saying calculate capacitance and rate of change of potential difference dV by dt. They are asking two things. They are asking capacitance. They are asking, and they are asking rate of change of potential difference between the plates. Okay. So how to solve capacitance? This is a very simple formula. Tell me the formula for capacitance. Note that nothing is kept. It is a vacuum everywhere. Tell me the formula for capacitance. Quick. Yes. Yes. Epsilon naught A by D. Good. Substitute epsilon naught A by D. Substitute. Epsilon naught value, all of you know that. 8.85 into 10 to the power minus 12, right? Minus 12. uh, area of the plate, pi into r naught square. R naught is how much? 12 centimeter it is. So 12 square centimeter square means 10 to the power minus 4 will also come, divided by d, distance between 5 centimeter. So 5 into 10 to the power minus 2. This calculation we have to do that. Why don't we take 4 pi epsilon naught factor? It may look easy calculation, isn't it? Right? I will keep epsilon naught as epsilon naught. And this 4 factor I want, so I will multiply 4 and I will divide 4. So 4 pi epsilon naught is 10 to the power how much? 1 by 4 pi epsilon naught is 1 by 4 pi epsilon naught is 10 to the power 9. Correct? So 4 pi epsilon naught will become 10 to the power minus 9. Okay, so this 4 pi epsilon naught, 4 pi epsilon, this value I am taking as 10 to the power minus 9. Okay, now then what? Then remaining 12 square, 12 square, 4 can be taken as 2 square. So 12 by 2, 6 square, I will write as 36, right? And this 10 to the power minus 4 extra is there. And here it is 5 into 10 to the power minus 2. This looks easy calculation. Calculate this. Capacitance we will calculate now. 36 by 5 we can definitely do, because 5, 7, 35 and 0.2 we can take, and then this will become 10 to the power. This gone, right? Uh, how much? Minus 2, 9, 11, 12. Sorry, 9, 10, 11. This one, correct? That's all it is. Or if I want to write in pico, so 10 power minus 12 will go 72 picofarad. This will be the answer. Capacitance is 72 picofarad. Correct? Check out this. Clear? 72 picofarad. Calculation you should do. Okay. Okay, the next part of the capacitance is dV by dt. How to take dV by dt? So V is equal to Q by C we can write, right? Voltage is Q by C dt. So now I will take capacitance out and this become dQ by dt. dQ by dt is current, they have already given that dQ by dt. So that becomes I and this is C. So I by C is what we need to calculate. I is they have already given 0.15. Capacitance you can write in that terms, right? 72 pico means 10 to the power minus 12. You can definitely do the calculation. You can remove this decimal and calculate how much that will be. Remove the decimal, 10 to the power minus 2 will come. And here 3 factor I can cancel, I think. 3, correct? 3 factor we can cancel. How much? 3, 5 it will go. 3, 1, then how much? 42. No, 3, 2, sorry. 3 to 6, right? 3 into 2, 6, 1, and then 12, 3, 4, 24. 5 by 24 factor is coming. Try to get a factor for that. Let us write 50 by 24. Okay. So extra addition I am doing. So 10 to the power minus 3 I have to write. 10 to the power minus 3 plus 12 I have to write. Calculate quickly. 50 by 24 is how much? Quickly we can calculate. 50 by 24. 48 will come, and this 2 will come, 0.0. I think, yeah, approximately 2, let us take. 2.0 something will come. Okay. So let's take approximately equal to 2, and this is 10 to the power how much? 9, correct? 9. 12 minus 3, 9, correct? This is volt per second. Volt per second. Rate at which voltage is changing. Clear? Approximately. Clear? Anyone any doubt? Next part of the question is, second part of the same question is, obtain displacement current across the plate. They are asking displacement current. Find out displacement current. Second part. Find displacement current. Displacement current across the plates. So they have not mentioned what point we have to take. So displacement current, shall we take the same as that of this? If you want, you can derive it. Epsilon naught d phi e by dt, right? So same way you will write area of the capacitor into electric field, right? Differentiation with time. So epsilon naught area of capacitor will come out. Electric field is what? Electric field is sigma by epsilon naught. Differentiation of this by time. This will get cancelled anyway. Area of the capacitor. Sigma is what? Sigma is charge by area. Sigma is charge by area of capacitor will come out. Same way. AC also will get cancelled. So that comes simply as dq by dt. dq by dt simply it will come. It will come same as conduction current, which is already given as 0.15. Correct? That's what it is. So displacement current is same as conduction current if nothing is mentioned. But if they have mentioned some region, there we need to calculate, because the factor of area of loop by area of capacitor will come there. Area of loop by area of capacitor will come there. But nothing is mentioned means displacement current is same as conduction current. Okay. Yes. Huh? What? How much? Answer is 8 picofarad. Answer given is 8 picofarad. Check this. Any mistake has happened in the calculation. Epsilon naught A by D. Epsilon naught area is pi into r square. Radius is 12 centimeter. 12 square into 10 to the power minus 4 centimeter square, right? Ah. Then distance between the plates. Distance between the plates is how much? 5 centimeter. 5 into 10 to the power minus 2. I am multiplying 4 to get this factor 4 pi epsilon naught, which is 10 to the power minus 9. Then this I am keeping, and 12 square by 4 means 12 square by 2 square, 12 by 2 6 square, 36. 10 to the power minus 4. Then 36 by 5 is how much? Correct or not? 5 into 7, 35.2. This is only what we are getting. Check this calculation. Any mistake is there? Good. Otherwise, keys might be, sometimes keys are mistaken in CRT, or they might have rounded to some very gross rounding off they might have done. Might be they have taken epsilon naught as 8.85 into 10 to the power minus 2. Like that they have done calculation, and then might be they have rounded on. But definitely if they round off also, it will come two-digit figure now. It will not come one-digit figure. Is it 8 picofarad or 80 picofarad? Any calculation is going wrong, check out that. 8.11 it is coming. Check out this. Two different answer cannot come. Anything mistake in this? Epsilon naught area by d epsilon naught area is pi r square 12 square, but centimeter square is 10 power minus 2 square 10 power minus 4 will come. 5 centimeter 5 into 10 power minus 4. 4 I have multiplied to get this 4 pi epsilon naught as 10 power minus 9, and 12 square by 4, 12 square by 4, that is 2 square, so that becomes 12 by 2 6 square 30. That is not a problem. 10 power minus 4, 5 into 10 power minus 2. Then 10 power minus 2 comes 9, 10, 11 factor comes. 36 by 5 is 7.2. Huh? 80 into 10 to the power minus 12. Let me check out. Okay. Now I will take epsilon naught value. Calculation will check. So epsilon naught is 8.85 into 10 to the power minus 12, right? Area is pi into d square, 12 square into 12 square into 10 to the power minus 4. D is yes. So I have converted into meter now. Centimeter is 10 to the power minus 2. Square of that 10 power minus 4. Check this calculation. Centimeter we are converting into meter. Now I will check with calculator, okay? And then I will see what is the answer. Powers of 10 I will write here. So minus this as minus 10, minus 14 I am getting here, okay? This I am getting minus 14. Now let me check out this calculation with calculator. So 8.85 into 12 square 144 divided by 5 into 3.14. It is coming as 800, nearly this. So it is coming 8 into 10 to the power minus 12. 8 picofarad is coming. Where is the mistake happening? No? This is the exact calculation is coming. 8.85 into this divided by Here what mistake has happened? Why it is not giving the answer? Because that is 8 and this is 72, quite a lot difference is there. 1 by 4 pi epsilon naught is 10 to the power 9 only, right? So epsilon naught pi 12 square 10 to the power minus 4, that's correct. And this 5 into this. So in this I am multiplying a factor of 4 and 4. So 4 pi epsilon naught I am writing as 10 to the power minus 5. Okay, right. Oh, I missed this 4. 4, this extra 4. This 4. What about that 4? That 4 where happened? What happened to that 4? That 4 we need to divide by 4 now. Whatever we have calculated correct only, but we need to divide it by 4. Divide it by 4 and tell me the answer. Divide this by 4. So 72 by 4. Not coming, huh? Hey, where mistake is happening? Huh? What? Oh, 9 into 10 to the 9, 9, correct. 9 into 10 to um, 9 into 10 to the power 9, correct. So this will become 9 also will go in the factor in denominator, right? Because 10 to the power 9, we have to inverse that. So that means here 9 will come here. Okay, extra 9 will also come, correct? 9 will come. Then how much it is? Will it come? 36. No. Let me check again this calculation. Somewhere we made mistake. Epsilon naught pi into r square. R is how much? 12. 12 square into 10 to the power minus 4 by distance is 5 into 10 to the power minus 2. I wanted to use that. So 4 I multiply, right? Then this factor 4 pi epsilon naught is 1 by 9 into 10 to the power 9. Right? Into 12 is equal to 12 by 2, that I have written as 6 is equal to 36. And this is 5. And this is 10 to the power minus 2. Okay, 9 into 4. 4 by 5 it is coming. Into 10 to the power minus 11. Then it is coming, correct? So 40 by 5 into 10 to the power minus 2. Oh, that calculation mistake has happened. Before correct. Fine. Okay. Calculation mistake was there. Okay, got it. So I think then you check here also. This next step calculation mistake we have also made here. We have to change the values here, right? Change values and check how much answer is coming. Current is 0.15 and this is 8 picofarad. So 15 by 8 into 10 to the power how much? Minus 10 it will come then. How much this will come? Nearly 2 it will come, or 1 point something. You take that. Check out this calculation. 1.875. 10 to the power minus 10. Correct? So nearly 1.875 if I round off to 88, right? Into 10 to the power minus 10. Okay? This is correct. Check the answer key. Key also you check. Anyone can check and tell answer key. Oh, plus 10, right? Right. इस माइनस has come आपका plus 10 meters. Okay. Anyway, that's calculation. Please check that. Sometimes calculation mistake. So this is the answer for this. This is the answer for this. What about this answer? Same answer. Check that. Second part. Second part answer you check. Tell me is this correct or not. I will go next. Correct. Okay, next is Kirchhoff's first rule, junction rule, valid at each plate of the capacitor. Is Kirchhoff's junction rule valid for, suppose this is the plate of the capacitor and suppose current is coming like this here. So this current is what? This current is conduction current. But once you consider here there is electric field lines are changing. We don't see any current. So we may say that there is no current, so it's not rule is valid. But here electric field line is changing means there is a current which we are calling as displacement current, ID. So now clearly we can see that IC and ID are going to be equal, right? IC left side just before the current is entering this side. After current enters, that side is capacitor. So that is IC is equal to ID. Because IC is equal to ID, so Kirchhoff's Kirchhoff's junction law, Kirchhoff's junction law is valid, right? Because what is Kirchhoff junction law says? Current input is current output at the junction. So where is the junction? This is the junction, this one, at the plate when it is entering. So whatever current is entering, same current is going out, but the nature of the current is different. One is current in the wire, another is current in the electric field, changing electric field. Clear? Yes. Because we cannot say that Kirchhoff's rule is wrong. Because Kirchhoff's rule is based on the conservation of charge. This junction law, right? So that current which is coming here is transforming into another type of current. That's what it is. Just like energy, kinetic energy can convert into another type of energy like potential energy, but total energy remains constant. Same way here also, current is transforming into another type of current. That means conduction current and displacement current. So conduction current is transforming into displacement current, but still current is there. Clear? Yes. So you can write it like this way, that at this junction just before current is in the wire, which is conduction current, just after this point inside capacitor, current is in the form of changing electric field, which we call as displacement current. So definitely both are correct. So we can say that Kirchhoff's junction rule is valid. Okay, like that you can write. Then let us go to the next question. Next question also we'll try. 8.2. Try this question 8.2. Parallel plate capacitor made of circular plates. Similarly, like this type of questions are there. Again, another model of questions are there. Like this capacitor is there. Okay. They have given the radius of the plate. They are calling it capital R. So capital R radius of this is 6 centimeter. Capacitor is given as 100 picofarad. Capacitor is connected with a voltage. This voltage source is AC source. Okay. AC signal it is. This AC source voltage 230 means this is RMS. Definitely this is RMS. Okay. Not mentioned, it is RMS. Frequency radian omega also they have given 300 radian per second. What is the RMS value of conduction current? We need to calculate RMS value of conduction current. RMS value of conduction current. How to calculate? That is first part. Okay. Second part calculation is the conduction current equal to displacement current? Is conduction current equal to displacement current? Third part of question is determine the amplitude of magnetic field. We have to calculate magnitude. where 3 centimeter. Again, we have to choose a small r, which is 3 centimeters from the axis. Okay, right. So this calculation we have to do. Let us quickly do that. Let us quickly solve it fast. So we have to calculate RMS value of conduction current. This current is the wire. So what is the current? How do you calculate? Because they have given it's a AC circuit. So AC circuit just now we have studied omega. They have given C. So first of all, we'll calculate XC. XC is 1 by omega C. Let us calculate XC. XC 1 by omega. 1 by 300. Capacitance is how much? 100 pico. 100 pico 10 to the power minus 12. Calculate this, how much? 1 by 3, keep it as it is, 10 to the power you take out. Okay, so 2 to 4, that means minus 8 will come. Minus 8 plus 8 will come. Okay, this is what, and the unit is, Now let us calculate IRMS. IRMS is VRMS by XC. VRMS is already given 230 divided by XC 10 to the power 8 divided by 3. So 3 into 3 9 and 3 into 2 6, 69. And this factor of 10 will cancel out. So 10 to the power 7 minus 7 will come 6.9 micro ampere. Check out this answer now. Check out this answer and tell me whether it is correct or not. Correct. Okay. Next move to this, and of course this has to be equal. We don't have any argument on this, because whatever current is entering, that will transform into electric field. I ID ID, that ID we can calculate if you want, but no need, because that is what it is, dq by dt. Okay, so definitely yes, it is equal. We don't have to do calculation because it is based on conservation of charge. Even if you do, it will come the same thing. We can prove it if you want, because id is equal to epsilon naught d phi e by dt, and we have proved many times it will come same as dq by dt, unless we are taking a smaller region. Okay, so that is going to be same. Id is going to be same as that. But now in the third part of calculation, they are asking magnetic field at somewhere else. In that case, you have to take loop area difference, right? So we have to take like this, some loop area, right? So we have to multiply the factor now AC by AD. But then you cannot say that displacement current has become smaller. Okay, here you may misunderstand it. If I am writing displacement current like this only, but I am multiplying that area factor, because we are considering a smaller region. So that doesn't mean that current it's smaller. IC is become reduced. No. So we are taking a smaller region here. Now that radius we have to consider. Okay. Flux actually changes because the area is small, so flux changes here. Okay, so this is small area, it is small r. Okay. So we'll directly calculate magnetic field. That formula, direct formula, mu naught by 2 pi r. Let us directly apply that. 2 pi this r, right? 2 pi r into what? Area factor. Shall we take area factor? Area factor means what? Pi small r square by pi capital R square. This area factor we will take, right? Into displacement current can be directly multiplied, which we have already calculated displacement current, which is that one. Directly multiply that displacement current or IC. Okay. RMS, IC, RMS, we will substitute. Let us try to calculate. Are they asking the peak value or RMS value of magnetic field? That also depends what value they are asking. Determine amplitude. Oh, they are asking amplitude. We have to be very careful. They are asking amplitude here. That means V naught they are asking. So here you need to not take RMS. You have to take current, conduction current amplitude. Amplitude means not we will put. Okay. So you know that not when you put it is amplitude is root 2 times of that. You know that, right? Amplitude of current is root 2 times RMS value. Right, so that factor we will use. So root 2 RMS already we have calculated here. That factor was how much? 6.9 micro. That is 6.9 micro. Okay. So 6.9 microampere it is. So this value current we will use. Now let us apply this. This pi will anyway get cancelled. So mu naught by 2, mu naught is 4 pi into 10 power minus 7. So this 2 will come into 10 power minus 7 will come. R is how much? R means this 3 centimeter they are asking. So 3 into 10 to the power minus 2 will put. R by R means it is half, right? Square square that will get cancelled. So 1 by 4 factor will come here. And now we will put this root 2 into 6.9. Micro means 10 to the power minus 6. Let us try to solve this. Let us try to solve and check the answer. This decimal I will remove, so extra 10 will come. 3 into 1, no, sorry, 3, 2, no, 3, 2, 3, 3. Yes, 23 factor will come. Here these 2 also can be cancelled with 2. Okay, so check out this. So 10 to the power minus 2 here. Okay. 23 root 2 by 2 I am taking, and 10 to the power minus 7 minus 6 minus 13, and here it is coming minus 12 will come. Okay, check out this. Root 2 nearly 1.414, or if I take nearly 1.4, so that will become 0.7. So 23 into 7 is how much? 7 into 3, 21. 7 into 2, 14. Yes, 161 nearly comes, right? 161. Points only 16.1 nearly. So 16.1, let us take 16 into 10 to the power minus 12. Right? Tesla. Is it correct? Approximately 16 pico Tesla. Check your answer. 15.4. What is the answer? Answer you check. Answer NCERT key answer. I will also try to check the answer. 160. 16 point, that only it's coming. Nearly 16 will come. Check out the answer key. Anybody has the NCERT key, right? Check. What about others? Check. Come on. Check it. You must have NCERT. Book you have no. In the book answer key, in the appendix they will give answers. That's what. That's what will come now. 1.6 I am taking into 10 to the power minus 11. Correct only now. One digit. You want, you can take 2 digit more. Correct. That's the answer. Fine. So I hope you got it. 2 questions we have done NCERT in exercise. Mm, that's all I think. Afterwards we can see the problems. The problems are not related with that. Yeah. That's all. Displacement current, only this many questions are related. Clear. So done. NCERT done. But you have to keep on working NCERT exam plus another thing. Now there is a very good question. There is a good question. This book I have already I mentioned in the class also. It's a good book, but let us discuss that question here also. Let us discuss that question. So that question is, what is the dimension of uh, epsilon naught, first question is epsilon naught d phi e by dt. This expression is given, okay, and they are asking that what is its dimension formula. Dimensional formula is what? Dimensional formula. What is dimension? If they are dimension for, you know, this is displacement current, right? This is displacement current. So if this is displacement current, means this has a dimension of current. Current dimension is a power 1. All others are 0, 0, 0. That's what is the dimensional formula. Okay, that's the dimension because it's a fundamental quantity. Current is a fundamental quantity. Over. Next, let us go to next question. Capacitor is in series with, there is a capacitor and this capacitor C is in series with some resistance which is 10 ohm. Okay, the combination is connected, it is connected to a battery of 10 volt. Okay, find displacement current immediately after, and this switch is switched on, switch on, switch on at time 0, at time 0. So question is that find displacement current at time 0. Find ID displacement current at time 0 means immediately when you switch on, what is the displacement current? That is the question. How will you solve that? What is the displacement current? Write down the formula for displacement current. In case of this RC circuit, displacement current is V by R e power minus t by RC. Remember this formula. So if I take time 0, if I take 0, so ID becomes V by R only. Yes, time 0 if I take, ID becomes V by R. Now let us substitute V by R. Gain is over because voltage is 10 and resistance is also 10. So at displacement becomes 1 ampere. Correct? Yes. Okay, done. Move. If you have any question, ask. See, you need to ask questions if you have any doubt. Next part, next question. Figure shows a circular region of radius r. Suppose there is a circular region of radius r. Circular region of radius r, and inside this circular region there is a dot magnetic field. Electric field they have shown. Inside only they are saying. This shows radius r. Radius is capital R for this. This is center and this is radius. Outside field is not existing. Inside only it is existing. Is it mentioned in the question? The figure shows a circular region of radius r. A uniform electric flux is directed out of the plane of the page. Electric flux they have not mentioned, but they are saying electric flux is there associated with this. So that electric flux is coming out of the page and it is given as A into T. Okay, is some constant is time. Now this question is very important. Here most of the people will make mistake. Okay, what is given is electric flux. This is electric flux associated with the circular region. Okay, now what we need to do, we need to find out few important questions are there based on this. So first part of the question here is what is the unit of A? That is the first part. Second part is what is magnetic field? Find magnetic field for R less than capital R. And next, find magnetic field for R greater than capital R. Very important question. Okay, for NEET as well as JEE main as well as JEE advanced. Okay. So let us try to do that. Now here the very important thing is that they have mentioned that flux associated with this region. They did not mention uh, anything about where the electric field line is present here or see if I take now here very important assumption. If I assume that electric field is only limited within this space, I am going to make that assumption first. Electric field is limited only in this space. Now I will make more dot dot, more dot dot I will make. This dot dot indicates electric field line is only present within this. Outside dot dot I am not taking. But note that even if I take outside dot dot, even if I take dot dot outside, the flux of electric field lines within this region will be given same. Because while you are calculating electric flux, you have to take electric field into area. The area of this region is limited. Even the electric field may be outside this region. So in the question it is not very clear that is electric field present everywhere or is electric field only limited within that. In the question they have to mention clearly, but I am assuming that electric field is only present within that. Okay, so that's why I have taken dot dot only within that. Dot dot I am not showing outside. Clear? This is one assumption I am taking. Electric field is present only within the circular region. Okay, let us take this assumption and solve this question. So first of all, if you want to calculate, okay, first part you see, first solve. A they are asking, right? In this question, A you calculate first. So A is equal to flux by time, rate of change of flux, rate of change of flux. So one way to solve the unit of this is electric flux. What is the unit of electric flux? What is the unit of electric flux? Electric flux. SI unit. Anyone knows electric flux? SI unit. If you don't know, then you have voltmeter. No. Volt into meter, that is potential difference into distance. Okay, let us check that. So electric field into area, at least we can write. Electric field, what we can write? I think you are correct. Electric field is V by meter. We can write this. This is electric field is V by meter and this is meter square. Time is second. So yes, voltmeter per second also we can write. But what is the SI unit of electric flux? Is there any SI unit of electric flux? I think there was some network problem. What is the SI unit of electric flux? Weber is, what is Weber? Is Weber the unit of SI unit? Weber? Yes or no? Weber is SI unit of what? Magnetic flux? I think so. Magnetic flux only, correct? Weber is not this electric flux. Weber is magnetic flux. Okay, anyway, this answer is correct. Any other option also you can write, because electric field unit you can also write as Newton per Coulomb, right? Because electric field also I can write as Newton per Coulomb. Area will be meter square by time. This is another way you can write. Either you write like this or you write like this, Newton meter square per Coulomb second. Correct? Like this also you can write. Okay, let's move to the next question. Next question says that you have to calculate magnetic field. And this magnetic field will depend on displacement current, and calculation of displacement current will depend on rate of change of flux. So for that, first of all, we need to find out what is electric field. What is electric field we need to find out, because you want to differentiate flux, right? So rate of change of electric flux you will do. Rate of change of electric flux means electric field into area. and if you take a smaller region, then you have to do that. If you take larger region, you have to do that. So definitely, if you take a smaller region, calculation will be different. If you take larger region, calculation will be different. We must make sure that we do this, right? Otherwise mistake will happen. So first of all, we need to find out, based on this given condition, that electric flux is A into T. We need to calculate this electric flux is for the entire loop. So that is E into area is equal to A into T. Area means what? Area means this pi into capital R square. Okay, so first of all, we need to calculate electric field as a function of time. A by pi R square into T. Clear? So this is electric field. This is electric field as a function of time. Now coming back to this question number B. Question number B, what it says? We have to take a smaller radius. Smaller radius means what? Smaller radius means you are going to choose like a small radius like this, right? So when you calculate displacement current, for that case you have to write epsilon naught d phi E by dt, and that small area you have to take, that area small r it is, right? So pi r square into electric field, right? That is what it is, differentiation of this by dt. So when you take this out, so epsilon naught pi r square will come out, dE by dt you have to take. Now you will substitute dE by dt. So epsilon naught pi r square, differentiation of this you will do. So A by pi capital R square comes out. Dt by dt is 1. So you get this as the displacement current ID. What is the displacement current? We are calculating this displacement current first. Epsilon naught pi r square area by pi capital R square. This pi can be cancelled out. Right. Okay, we got it. Now you will apply the Ampere Circuital Law. Let us apply now Ampere Circuital Law. So integral of B dot dl is equal to mu naught into id. Now this becomes V into 2 pi r, and this becomes epsilon naught r square A by capital R square. Now what is the answer? You got the magnetic field. So this r get cancelled. Epsilon naught A by 2 pi capital R square into small r. Yes, this is what you are getting, magnetic field. Clear? Are you clear about this? Yes. Anyone any doubt in this? What about others? Yes, come on, tell me, others. Yes or no? Did you understand? Otherwise, it will be like same way as in this school. Hey, I want you to tell and communicate. Huh? You should communicate. Yes, no, what it is. Yes, Lalit. Mu not I missed here. Uh, where I missed mu not? Here I think I missed mu not. Displacement current I calculated, right? Mu not I missed here, right? Correct. Here. One extra mu not should be there. Because we have calculated displacement current in terms of this epsilon r square A by capital R square. Now when we have mu naught into id I am substituted, I think mu naught I missed out. So mu naught is also multiplied here. Okay, yes, mu naught is multiplied, right. Mu naught epsilon naught A by 2 pi capital R square R. Right. Then next part solve like that. Next part, you are taking a region beyond this capital R. Note that now you are choosing a loop beyond this capital R like this. But I am assuming that field is only present in this space. Field is only present in this space. So if field is only present in this space, even if you take larger space or larger area beyond this, it is not going to affect, because flux is only limited on up to capital R. Are you understanding? So when you are calculating the electric flux for the entire bigger region, you have to come up to capital R only radius, because flux is only associated with that region only, right? So that is where calculation will change. Okay. So when you are calculating ID, now in this case, epsilon naught d phi E by dt, you substitute phi E. Phi is area, but which area you will take? Even though you are taking this small r, which is larger than capital R, you have to take only this r because field is only related with this. That means area you are taking pi capital R square into electric field by dt. So epsilon naught pi capital R square comes out. dE by dt, already we have calculated dE by dt you do. So E by pi capital R square. So this get cancelled, and that's what it become epsilon naught E. Right. So now you will calculate displacement current over magnetic field in the same way. So Ampere circuital law, 2 pi r, you need to divide by this mu naught into displacement current divided by 2 pi r. Do this. So mu naught, this has become epsilon naught A by 2 pi small r. That is the answer. Clear? Yes. All of you are clear about this? Yes. Anyone, any doubt? Okay. Monish, Dalit, Hari, all of you. Whom is okay. Then let us move next. I think we are done. That's a very, very important question. But suppose in this question now, suppose they say that field is existing everywhere. Okay, now let us modify this question and assume that the field is present everywhere. Everywhere field is present. And note here that they may also ask you the graph. Okay, all of you should know the graph. They may ask how the graph of B versus radial distance look like. So if you see initially that is proportional to R, this graph will be a straight line, and after this is capital R. Beyond this you are seeing this is inversely proportional to R. So this is a rectangular hyperbola. This is a straight line. This you should remember. Okay. This graph is a straight line, and this graph is a rectangular hyperbola. If for this case I have assumed that field is only present, but now let us say electric field is present everywhere, redo this calculation and see what type of graph comes. Is there any change or not? Let us do that. Suppose field dot dot is present everywhere, dot dot is present, and they have given a region of capital R. For this they have given the electric flux phi E. Phi E is nothing but E into this pi r square. They have given us A into T, so I have calculated electric field as AT by pi capital R square. Now I want to calculate for a region smaller than this. I want to choose a region which is smaller than this. This radius I am choosing smaller. Let us do this calculation. So displacement current calculation will be epsilon naught d phi E by dt for this smaller region. R is less than capital R, this we are choosing. So epsilon naught, here same way, differentiation of E into area pi r square by dt. So epsilon naught pi r square dE by dt. There is not going to be much change in this. dE by dt will be same E by pi capital R square. So epsilon naught R square by capital R square into A. Then magnetic field for this region is same way, 1 by 2 pi r will divide it. So mu naught into displacement current by 2 pi r will divide it. So epsilon naught mu naught epsilon naught r square a by capital R square by 2 pi r. What do we get from here? Mu naught epsilon naught, that r will get cancelled. A times this is a mu naught epsilon by 2 pi r square into small r. Yes. Is it this similar way what we have got previously? Check out this. Same thing what we have got previously. Mu naught epsilon a by 2 pi r square into small r. Correct? But what happens if I take a region beyond this? Suppose if I take a region beyond it. Now, if I am taking a region beyond it, this r is also now here also for this region also electric field is there, so there won't be any change in this calculation E into pi r square. So I think we are going to get the same result. Okay, for r greater than r also you will get the same magnetic field result. Yes, because magnetic field is not limited, here magnetic field is present everywhere. So the graph is always going to be a straight line here, that you note. Graph is always going to be a straight line, always going to be a straight line. Are you understanding this? Yes. Anyone, any doubt, any confusion? Done. So today we have completed up to this displacement current. We have solved problems also. See, the thing is that as much as you discuss, it will benefit you. That is what, because I want your interaction participation. The more you interact, and because this is what is not available everywhere, right? Even if you take anywhere, that thing will not be available. Here, that I am making you available. You discuss. Don't be shy. Okay. Class, there is time is not there that much. You cannot discuss. But still, I am available to discuss in the class also. Those who want, you can go slow as much as possible. But the thing is that you have to understand things. So it's more important that you understand things, and of course, formula you will remember once you know everything. Right? Practice is needed. So today we have done that. So next topic we will cover in maybe tomorrow we can cover that next topic. Nature of electromagnetic waves, sources of electromagnetic waves, energy formula, energy density formula, Poynting Hooker formulas, all those things we can see that. Fine. Yes. So let us take up the next class. Thank you all for your attention. Well done. Yes.